part 3 and the final part in a series of 3 for section 7.2 videos. So these are the proof problems. Determine the following pair of functions are inverses of one another. Now, for reasons I'm not going to bore you too much with, you might be thinking to yourself, well, hey, if I do the whole x and y switching thing and see if they match one another. And in this case, to be honest with you, linear equations, that would work. But you're just going to have to take my word for it when I say it doesn't work for every kind of equation, which is why we're going to show you this method instead. So back in Chapter 7, Section 1, we taught you how to find f of g of x, called a composition of functions. F of g of x. And there was a reason when you were working on all those homework problems and review problems that they made you do both versions and had you flip it around and do g of f of x. And it wasn't just for the sake of practice, it had an actual reason. And now you're going to see the reason. So this is it right here, literally. This is what we have to do a proof. So we have to do both of these, and I will wait to show you the outcome to see how we conclude whether they're inverses or not. All right, so if you remember how this goes, you are supposed to take the g function, the entire problem, and pop it into the f problem. So like writing it this way, here's the f problem. And I know something has to go in place of the x, because every time we say of, f of means something has to go there. And well, what goes there? Must be the other problem, because I don't have a number to plug in. So the other problem is 4/3 x plus 8. And it's just a matter of you doing the math. So a little distributive property here. Well, the 3/4 and the 4/3 would cancel, and you'd be left with just x. 3/4 times 8, you can always pick up a calculator to figure that out. But I'll tell you it's 6. And what would happen to 6's? Well, they would cancel. So I have left an x. Interesting. So let's try the other one and see what happens. So this time, I got to go vice versa. So if I read this, I'm going to say g of. And if I'm saying g of, that means something has to get plugged into the g function. So I'm going to leave a blank space, write out the problem, and then I'm going to try to figure out what gets plugged in there. Well, again, I have no number to plug in. It doesn't say f of 2 or g of 6, so I have to plug the entire other problem in. So take the f problem and plug it in for x. And again, do some math. Oops, I left the x off by accident. There we go. So 4/3 times 3/4, kind of similar to the last problem, reverse order, but you end up with an x. Pick up a calculator if you want. 4/3 times 6, or negative 6, is negative 8. And not coincidentally, the 8's also cancel, and you're left with x. So here's how you determine if they are in fact inverses of one another. You must get x for both answers, not 2x, not negative x, not 3x, not opposite, not reciprocals. Both have to be x, and they are. So these two guys are in fact inverses of one another. So one last problem here, a little tougher. So same process. F of g of x, f of. So as soon as I say f of, I know something's got to go in place of the x for the f function. Well, what is that something? That something has to be the other problem. And the other problem is 1/4 x minus 3. And again, a little distributive property. So this is looking good so far. 4 times 1/4 is x. So the same thing happened on the other problems. But if you pick up a calculator and you go 4 times negative 3, you obviously don't get negative 1/3, you get negative 12. Okay, now at this point, guys, I think it's pretty darn obvious that we're not going to get x for an answer. However, here's the thing with math. If you're proving something, you're supposed to prove it, as in don't quit until you have done everything there is to do and then finalize your answer. So the fact that there's a negative 12 and a plus 1/3 means you should pick up a calculator and go ahead and combine those. Because if you haven't, you're not giving me simplest form. So you could come up with negative 11 and 2/3. You could have even done a decimal. You could have done an improper fraction. It doesn't matter, just as long as you actually take the time to do it. So did this guy equal x? Well, no, he did not equal x. So if to prove two functions are inverses of one another, they both have to equal x, would it even be necessary to do this guy over here? And the answer would be no, because even if he was x and is not going to be, it doesn't matter because this guy was not x. So probably the best case scenario for you guys right here, if you get that first one not to equal x, you get to quit. And you don't have to do the second half of the work. So the answer to that guy is no, they are not inverses. Let's come back over here, though, just to double check and make sure you understand. They both have to be x. So if you do get one that equals x, you can't quit right there. So one more time. To prove two functions are inverses of one another, you must do a composition of functions for f of g of x and g of f of x. And if they both equal x, you get a yes. Otherwise, it's a no. All right, guys, that concludes section 7.2 and is also the end of chapter 7. So, yeah, thanks for watching.